Welcome back to part 2 of the Perfect Amplifier video series. And in this video, I'm going to interview the designer of the Purifi Eigentakt module, Mr. Bruno Putzeys. And I'm doing this because not only do I have a number of questions about why did he set about doing it when he had already designed some pretty successful Class D amplifiers in the past? What are his plans for the future? But I'm also going to ask some rather technical stuff that I and other people are very interested to know. And one of them is about feedback. Class D amplifier designers always seem to use feedback loops, which are obviously a lot of other designers say, no, you must never do this. I'm also asking him about GaN technology versus silicon, because that's also something that's becoming a hot topic. So this interview is rather technical in places, but I hope you enjoy it nonetheless. And so all I have to say now is, Mr. Editor, please roll the interview. Welcome to my listening room, Bruno. It's lovely to have you here. It's so exciting to be in the same room as your products, which I enjoy and listen to. And I just wanted to ask you a few questions, if I may, on a number of topics. But the first one is, what inspired you to redesign or rework your Encore module, your UcD module?
Basically, because there was room for improvement. That's the long and short of it. Initially I was mostly curious to see how much further I could get, and whether that would and how that would be reflected in the sound. Because of course, I mean, if in the end you design a better amplifier and it doesn't actually sound better, then there's little point in that. So it was really, well, I just wanted to have another go.
Yeah, but at the time when you first came up with it, when was that? 2013?
Well, my Class D history is a bit longer than that, but the good old UcD concept was born in 2001.
Oh, right. Okay.
And that was while I was still working at Philips. And then we started looking for people to license the technology, and one of those licensees was Hypex. And after a while, I joined Hypex as a result. So most people have only heard of UcD sort of after the 2005-2006 when I changed, and then Encore was initially designed roughly around 2008.
Oh, okay.
So after we'd been going for a bit.
But at the time, when you looked at the specifications and you looked what else was happening on the market, I mean, it was, I think, light years ahead. So there must have been a point that you sort of turned and thought, you know what, I can make this better. Was there something that triggered that off, or for you?
It's probably more a tactical thing. I didn't like the idea of being one-upped by other people. So you shouldn't be looking around or looking behind you and see who's coming up behind you. You should be racing yourself. And that's what I've been doing most of the time. So it was really like okay, at some point, what UcD, it's good, sounds nice, and so on. And at that point, there wasn't anything remotely as good as that. But still, I thought, well, clearly, technically, there are things that can improve. I want to be the one doing that, not someone else.
Yeah, nice.
So. In all honesty, it's just the way that I like to compete, by simply. Well, it's essentially like the final stages of a Tour de France, where people have to race themselves. Because they've got no one else to race against.
Yes. No, indeed. Okay. I mean, I totally get that. So somebody who's invested in an Encore or whatever, maybe built them their own modules and stuff, that is there, what would they experience differently if they then went for the Purifi Eigentakt?
Well, if they might actually have previously experienced the difference between a UcD and an encore, and
Right.
essentially there is a kind of linear progression between UcD and encore and eigentakt, which is that at each point in the stage, I develop new mathematical tools in order to be able to get more loop gain around the output stage, i.e. more feedback, to put it plainly. And so the change from UcD to encore, that was immediately a change in what you heard was, so you could take a UcD amplifier that you spent ages tuning to get nice even balance and so on, and the encore would just immediately do something much better with much more ease. So you'd hear that it wasn't straining to get to get a much better balance, to get much nicer detail without being oppressive or trying to sort of throw it into your face. But what I mean is just the there-ness of the sound and so on. And what I see is then when I moved from encore to eigentakt, again the same thing happened. The sound became finer, warmer, more emotionally more involving as well, softer, gentler. And that's been the progression. So the technical progression is very clearly mirrored in that sonic development of the amplifier. So what people should expect when they move from encore to eigentakt is basically more relaxed, more open and warmer.
Ah, interesting, because that brings up a topic that my colleague AJ in London and a friend of mine also would like to ask you, is that in the audio industry, with audio files, that feedback and feedback loops is, it's really a no-go area, but D-Class and your designs use it all the time. Is this something different happening in this architecture that makes it work?
No, actually not. I would almost say that the reverse is true. Sort of the current state of the art for me in terms of numbers. So the modules that I brought into the shop this afternoon, they have more than 80 dB of feedback up all the way across the audio band. Doing that in a linear amplifier is much easier, but it's not trivial. And I think what happened is that when people started designing Class D amplifiers, none of us was so inured in this whole audiophile business, and so and so there was no mental block to trying out feedback. Also, I think everyone who's anything in Class D has at least partly a background also in the design of A to D and D to A converters, sigma delta modulators and so on, and the techniques that you deploy in a sigma delta modulator to remove the noise from the audio band are very much the same feedback techniques that you use in a Class D amplifier to remove the distortion from the audio band. So with that background, you already have sort of the mathematical grounding. Like, okay, how do we do that? And this way of doing it is very different from how it's being taught, let's say, in classes of traditional amplifier design. In traditional amplifier design traditional amplifier is basically what we call a first order loop. Meaning that the loop gain will drop by a factor 10 if you move the frequency up by a factor 10, and that's a huge limiting factor, because if you want to have, say, if you want to have 80 dB worth of loop gain at 20 kilohertz, using that kind of thinking, you need an amplifier with a bandwidth of 200 megahertz. So that
I don't have any in the listening room that can do that, I'm afraid.
exactly. But the same thing happens when you're doing noise shapers and delta sigma modulators and so on. You are working inherently in a limited bandwidth. So you learn how to design so-called high order loops, and you learn how to calculate them, which is sort of really not an intuitive thing at all. So coming from that area, it's for a Class D designer, because of the relative, how should I say,
Ease,
simplicity? No, because of the resemblance between a Class D amplifier and a sigma delta modulator. It's sort of you sort of naturally try and use these same techniques and adapt them to amplifiers. But of course, if you'd ask me, can you do a linear amplifier and wrap a similar loop around it? No problem at all. But it's just like no one's waiting for a better diesel engine. No one's waiting for a better Class A amplifier.
Yeah, that's very true. Yes.
But make no mistake about it. A Class D amplifier is much harder to tame than a linear amplifier, and you have to work much harder at it, because I mean, the reason why I do Class D, to be brutally honest about it, is efficiency, so that you can make a small amplifier that doesn't waste a lot of heat. That's why I do it, and everything else is just making your life difficult. So no, unfortunately, if people think that it's sort of a natural and simple thing to do feedback around Class D amplifiers, no, it's not. It's just because you buy amplifier modules from the likes of me, and I've done the homework, so that makes it look easy. But actually, it's absolutely horrible in terms of complexity.
So, leading on to this point, developing your point earlier, things are difficult. I've noticed, Bruno, that your leadership team is really, really impressive. I mean, it reads like a who's who of digital technology. You've got Lars Risbo, who's a lot of experience in direct switching amps. That's an understatement at TI. Klaus Nesgaard, Kim Madsen, applications manager on the Ariane rockets, which is no small thing. Soren Paulsen in R&D, the guy who produced the world's highest powered IC amplifier, if I'm correct. Yeah. Then you got Peter Lingdorf, that we all know from Dali, and Lingdorf, of course. I mean, and then Morten Halvorsen on the transducer side, and Carsten Tindgaard. I mean, what are your coffee times like? I mean, tell me a bit more about that. Is this one of your ideas to get these guys together?
Well, to start off with, it's an enormous luxury to be able to work with these people, because as someone famously said, if you're the smartest person in the room, you're in the wrong room.
Yeah.
And I feel that during parts of my career, I was in the wrong room. But here, I mean, this actually really started because of Lars. So Lars and I have been meeting each other at AES conventions and so on, every now and again, and doing papers and really hitting it off like a house on fire, and always leaving with a feeling like I need to do something together with this fella. And he, of course, at that point so he'd sold his consultancy to Texas Instruments.
Yeah.
So the people that you mentioned, the team those are essentially sort of the core team at TI and Lyngby. And it was really only at one point that I said, Lars, it's now or never. I mean, we really need to do something. And then we got in touch with Peter, and would he help us start something up? And in a way that the timing was fortuitous, because TI was reorganizing and was shutting up shop in Denmark. And so essentially I just suddenly found myself with a pre-made team of absolutely brilliant and absolutely lovely people.
Yeah.
that's how it came about. So there was really not that pre-planned at all.
So it shouldn't really be that surprising why Purify is so successful now and why it sounds so damn good. I mean,
Yeah, it is well, basically Purify is more than the sum of its parts. I mean, that's also an important thing to realize, is because I mean, Lars, as you mentioned, so he's best known in the hi-fi world for the Tech Millennium, and basically all of Steinway Lindorf's amplifiers are still based on the work that he did then. But he's now the guy who's driving much of the transducer work.
Yeah.
So I'm acting as a sounding board for that, but he's actually he's actually really at the core of that, just showing that he's an engineer through and through. He's not just an amplifier guy. He's simply an engineer who likes audio, who likes music, and who can apply the same style of thinking to loudspeakers as he did to amplifiers.
I find that very interesting because, you know, I've just come back from visiting Riga in the UK, and Roy and the team there, you know, you get like Roy really into music, tries to play the guitar, plays the guitar, but he's also an engineer, so he's looking at all the different angles. And I think that's what, in the end of the day, makes a big difference, to surround yourself with people who are not necessarily always thinking the same as you, but also trying to solve problems which are alien to them, i.e. that they're applying their way of thinking to a different problem which they're unfamiliar with.
And this is what we're also seeing. So not just Lars and myself, so because both of us now with, let's say, 1 foot in amplifiers and 1 foot in drivers. Me a bit more with amplifiers, and as I said, he mostly with the drivers. But the other TI guys as well are Kim and Søren, who do application engineering for the amplifier side. They actually also do the application engineering for the speakers.
Yeah, it's nice, isn't it? And it must be refreshing for them as well, because they're not always having to try and solve the same problem.
Yeah, I do have a suspicion that they're enjoying themselves.
Well, that's that's a good thing. Now, I've got a little bit of a controversial question for you here. We are seeing more and more talk about GaN FET amplifiers. Have you got any comments or views on that, or thoughts on it?
I think, let's say, starting from let's say a voltage rating of 200 volt, GaN FETs are definitely superior to silicon. But so let's say if ever I do an amplifier that goes into the multi kilowatts, it will be a GaN or maybe silicon carbide amplifier, i.e. an IV semiconductor type type switch, so wide band gap. But what I see is that gallium nitride is kind of being misused by people. Well, not misused, but in a way that because a lot of people, as I said, don't really know how to do a good modulator, don't really know how to do a good feedback loop, and so on, and they try to they try to buy some performance margin. By using faster output devices, i.e. gallium nitride FETs. But the thing really is that if you compare the switching speeds of modern silicon FETs with gallium nitride in the sub 200 volt range, so up to 150 or so or something, the margin is only, I don't know, about 10 dB in terms of distortion or something. So if you swap in a low powered amplifier the silicon FETs for GaN FETs, it only makes a 10 dB difference. Whereas, of course, as I said, doing feedback loops that reduce distortion by 80 dB.
Yeah.
So in a way, it's simply not good use for the money, because the feedback loop, that's basically a fairly low cost op amp with a largish number of very cheap passive components around it. So the only thing it costs you is design time, and then you can do. I mean, the sort of result that I get with silicon is well beyond what anyone else can do with gallium nitride. So so that's why I'm saying, for me, gallium nitride becomes interesting when you are actually entering sort of current and voltage territory, where silicon really gets clumsy, and that's above 200 volts.
Yeah, okay, but then that's a completely different application. So we've been listening to this afternoon to your prototype for the higher powered Purifi, and it's sounding absolutely wonderful, and it's going to open a lot of doors for possibilities of different types of buffers, or no buffer, and coupling, and all sorts of things for the future. But what's next for you? What's next for, what do you see as the next big step for you or your team, or what can we expect?
Well, I'm taking a short. I mean, after this bigger amplifier comes out, I mean, again, compared to the current generation of Eigentakt, it has significantly better performance. So I mean, we are now at distortion figures that are closer to minus 130 than 120. So
yeah, and one of your colleagues is one of your people who's working with it now and enjoying it. He said to me on the phone yesterday from the States. That he said Warren was saying that it's just so musical. It's something's happened in that module that
exactly. It is very much that, and so once that comes out, I can take another break from amplifiers and actually put work in something very pedestrian but very necessary, which is a power supply.
Okay.
Because currently, of course, we simply suggest that people buy power supplies elsewhere, and it works fine. But our product range is not going to be complete without a number of power supplies. And in the past, I've always relied on colleagues to do that. So now it's really like okay, let's just try and do something different. And of course, the power supply, in a way, for an audio person, it's nothing exciting, because especially with the way I design these amplifiers, is I design them to be as insensitive to the noise level of the power supply as possible. So in other words, the power supply really is simply a crude bit of hardware between the between the 240 and
yeah, but there are people playing with Purifi modules and linear power supplies. Are you going to go down the linear route? Is there any advantage in that, do you think?
Not that I know, because I find generally, and that especially when you have a power supply that's simply designed to have very low EMI and so on, actually the linear power supplies have no advantage over it. I mean, the big advantage of a linear power supply is, of course, is that you don't have to rely on the availability of a switching power supply. You can also make a bit of a song and dance about your usage of a linear power supply, because there is still a certain subculture that thinks that they are better. But as I said, for now, the plan is actually, as I said, really pedestrian, just something that you can put in a box with our amplifier modules.
Well, absolutely, and this is why I especially like it, and AJ as well at Pearl Acoustics. Why we like that module is the fact that people can put it in a box and they can forget about it. That's one component that they know is performing very, very well. They can do what they like with a product designer, somebody down the road, an art student can come up with something that looks beautiful on the table, or they can put it in the cupboard. If you don't mind us putting your stuff away in the cupboard, out of sight. I just enjoy it.
I tend to hide the stuff at home as well. So it's
doing your job.
It is, and it's always been very much my plan with power amplifiers anyways, to turn power amplification into a commodity. That is to say, well, look, no matter what performance level you're aiming at for your product, just buy this module and the amplification part is solved,
Yeah.
and then you can concentrate on building a great user experience around that.
Yeah, fantastic. Bruno, thank you so much for coming in today. It's been a pleasure talking to you.
Thanks
and
for
I
having
look
me.
forward to everything. And enjoy your breakaway from amplifier design. You've deserved it. And we look forward to that power supply coming out sometime in the future.
Lovely.
Thank
Thanks.
you. Bye.
Bye.